Hello, my name is Saurabh Dongol and my student ID is S00393546, and this is the assessment of Introduction to Data Science with Python, and the assessment is about the data processing and exploration project for semester 2, and date of submission is 20th of October 2024. In this assessment we are going to explore BRFSS data. The data set for this assessment is given by the lecturer in the canvas. The given data is in the CSV form. Here we do is data processing, analysis and visualization of the given data. In the data set there are 414,508 rows and 6 columns. The 6 columns are age, current weight, weight in a year, current weight, height, gender. Here the gender is denoted by 1 and 2. 1 represents to male and 2 represents to female. In the section 1 we summarize the statistics analysis. Here we do this by different steps. These steps are importing libraries, loading the dataset, computing summary statistics, extracting values and plotting, setting up the plot, defining makers of the plot, creating scatter plots, and finalizing the plot. Is the code. In this code we use different methods to extract the final outcome, and some of them are mean, standard deviation, minimum and maximum values, median, 25th and 75th percentile, and here is the final outcome. Here we can see the current weight in the kg and the weight a year ago, and the height, minimum and maximum height. Here you can see mean, max, mean, median, 70th percentile, 25th percentile. On the task 2, we have to calculate the weight change analysis using Pearson correlation coefficient. Here is the code to calculate it. To calculate the weight change, we have to know first the current weight and the previous weight that is a weight a year ago. And to calculate the difference, we have to plot against each other. Is the first scatter plot, weight change versus the current weight. Here is the current weight versus the weight change, which is generated by these blue dots. Similarly, this is the scatter plot of weight change versus the weight a year ago. Here is the weight a year ago, and here is the weight change. And this is the scatter plot of the weight change versus the age. Is the age from the 20 on this side we have got age, and this side we have got the weight change. And finally, the task 3 is about the visualizing the price prediction. This is done by using the linear regression. Here is the code. In the task 3, we have to predict the house price based on their size. For this, we have to import the different libraries using this code. We have to find the price for the 2,500 square feet home, and the final answer we get is 326,000 using the linear regression. Then we come to section 2, correlation analysis. We use this correlation analysis in the task 2, which is the Pearson correlation. This is the formula to calculate the correlation, where x and y represents the two variables being compared. And The scatter plots generated from the analysis is are weight change versus current weight change versus weight a year ago, and weight change versus the age, which I already described before. Here we compare the three factors against each other. Weight change versus the current weight change, and the weight change versus the weight a year ago, and weight change versus the age. And section 3, significant analysis. We use this analysis in the task 3. We use the linear regression model to do this. We forecasted the house price based on their size. On the data set, we are given the house size and the square feet versus the house price. Using the analysis, we calculate the price of the house of 2,500 square feet, which is 330,000. Finally, in the conclusion, what I have concluded is that in the task 1, showed a slightly rise in the average weight over the past year, indicating a possible downtrend towards the weight gain. Similarly, in the task 2, we use the Pearson correlation with both current and past weights. In the task 3, we use the linear regression for forecasting the house price based on their size. Overall, the findings highlight importance of statistical methods in revealing patterns and correction of health in real estate, providing valuable insight for further exploration and practical use in both areas.